All right, so this is section 2.4, part 2. Still talking about the remainder and factor theorems and how we can divide polynomials and what type of information it gives us. So with this, we're still doing the same thing. We're going to learn how to use the factor and remainder theorem. And we're going to talk a little bit about what the remainder theorem is. This is kind of a fancy way of saying it. We don't really use this a ton in practice. So it's more a little bit easier to just kind of get into how we're going to use this. So the first thing we want to talk about is we're going to look at this story problem here. And I know that you've done this before in Algebra 2, but basically we have a story problem that says the number of tickets sold during the Northside High School football season can be modeled by t of x equals x to the third minus 12x squared plus 48x plus 74, where x is the number of games played. Use the remainder theorem to find the number of tickets sold in the 12th game of the season. Well, you probably don't need to know the remainder theorem to actually do this. If you realize that 12 represents the number of games and x represents the number of games, then most of you could probably just say, oh, well, I'll just do 12 to the third power. Oh, that's not a plus, that's minus. 12 to the third power minus 12 times 12 squared plus 48 times 12 plus 74. So you could absolutely do it that way, and you get an answer. And when you plug that in, you'll get 650. That is awesome. Okay. The other way you can do this is something called synthetic substitution. So it looks like synthetic division. We use the value that we want to use, or that we were given, 12, and we put in the coefficients of all of our values up here. And then you go through and do exactly what you would do if it was synthetic division. Bring the 1 down. 12 times 1 is 12. Negative 12 and 12 is 0. 0 times 12 is 0. 48 plus 0 is 48. Okay, you keep going there. 12 times 48 is a large number, 576. Yep. Okay, and then 576 plus 74 is 650. Okay, and you see this number right here is the exact same number you get if you were to plug it in. So either one of these works. Just sometimes if you remember some synthetic substitution, it's quite a bit easier and a little bit less likely to make a mistake like what you do over here. But it's up to you which way you want to use that. The next thing, this is the factor theorem. So basically what we're talking about here is that if we know that we have a factor, okay, then as soon as we have a factor, that means we know what one of our zeros are. Okay, so whatever our c value is will always be our 0. So if it's x minus 5, then 5 is a 0. If it's x plus 2, then negative 2 is a 0. We've talked about this over and over and over again. Okay, so we want to be able to apply this now. So in other words, what we have here is we have polynomials that are higher degree. And what we're going to do is we're first going to determine whether x minus 1 or x plus 3 is actually a factor. And what we can do is we can use synthetic division to determine this, because synthetic division would say if we can divide x minus 1 into this without a remainder, then that means that is an actual factor of this function. And if that's a factor of our function, then we know what one of our zeros are going to be, and we can take that further. So we're going to do these one at a time. We're first going to start with x minus 1. When you synthetically divide, you need to use the 0, not the value that's here. So the 0 here would be 1. So when I synthetically divide this, 1 is going to go on the outside. We have 4, 21, 25, negative 5, and 3. Okay, so then we go through and do our synthetic division here. We bring down the 4. And then 1 times 4 is 4. So that's 25. That's 25. 25 and 25 is 50. That's 50. That gives us 45. 1 times 45 is 45. 45 plus 3 is 48. And as you can see, that's not a remainder of 0. So because it's not a remainder of 0, it will not be one of our factors. So now we're going to try negative 3. Because again, x plus 3, which you see on your paper, that would yield us a 0 of negative 3. So when we put this in, we do the same coefficients. 21, 25, negative 5, and 3. Okay, bring down the 4. 4 times negative 3 is negative 12. That gives us 9. Negative 27. That gives us negative 2. Positive 6. 1. negative 3, 0. Perfect. So we have a remainder of 0 here. So therefore, x plus 3 is a factor. Okay? So we know that x plus 3 will be a factor of what we have up here. Okay, let's go to the next example and talk about how we're going to actually use this. So now we want to check to see if x minus 2 and x plus 5 are factors. So again, we're going to go through this the same way. We're going to first do 2. So we have 2, 3, negative 1, negative 22, and 24. Bring the 3 down, 6, 5, 10, negative 12, negative 24, 0. Perfect. So we know that x minus 2 is one of our factors. So let's check negative 5 and see how that works out for us. So 3 times 5, negative 5 is negative 15, negative 16. Then we're going to get 80. This will give us positive 58. And then we get negative 290. And this gives us negative 260, which clearly is not 0. So x plus 5 is not one of our factors. Now, what do we do with this? So the idea is that if x minus 2 is our factor, then if I were to go through and actually try and factor this function right here, I know that x minus 2 is going to be one of my factors. So what synthetic division allows us to do is, now that we've divided it, what is left is going to be what function is left over. So if we started with a cubic and we divided out an x, or an x minus 2, then what's going to be left over is going to be a quadratic. And these numbers just represent the coefficients that go in front of our x terms. Okay, so now that we have x minus 2 and a quadratic, if we wanted to continue to factor it, we can, because this is a quadratic, so we can continue to factor it. So we still have our x minus 2 here, and now we're going to create new factors. So we're going to do 3x and x, and then we're going to just try something here. Let's try, so the factors of negative 12, let's try negative 4 and 3 and see if that works. And again, you can always try different ones, but let's just see if this one works. So again, remember, we only care about the middle terms. So we only care about the outer and the inner. So that ends up being 9x, and negative 4x is equal to 5x. And that does match up. So this is our fully factored form of this equation up here. And we did that all by using synthetic division. Now, we were given what one of the potential factors were, so that did help us continue on. But this is going to become important with what we do in the coming section. Okay, for this one right here, I want you to do this one on your own. So do it on your own, and I want to see what you guys get, because this could get a little bit interesting. I would like you to find out if x minus 6 and x minus 3 are factors, and obviously label if they are. But if they are, or if one of them is, I want you to continue to factor and see if you can get the final answer. Okay, so let's see what you come up with. In the answer on Edpuzzle, though, I'm only going to have you write whether they are factors or not. But I'd like to see you see if you can figure out what the fully factored form would be, and then bring that to class with you. All right, so try that, and then I'll go through this. And actually, you know what? No, don't even put this in Edpuzzle. I take that back. Do this on your own, bring it to class, and this will be the first thing that we go over in class. All right, I will see you then.